Hello, my name is Catarina Reis. Welcome to the course of Design and Testing of Software. I'm here to guide you through the topic about tool support for testing. Test tools can be used to support one or more testing activities, including tools that are directly used in testing, such as test execution tools and test data preparation tools, tools that help to manage requirements, test cases, test procedures, automated test scripts, test results, test data, and defects, and also for reporting and monitoring test execution. Tools are used for analysis and evaluation. Any tool that assists in testing, even a spreadsheet, is also a test tool in this meaning. Test tools can have one or more of the following purposes depending on the context. Improve the efficiency of test activities by either automating repetitive tasks or tasks that require significant resources when done manually, and supporting manual test activities throughout the test process. Automate activities that cannot be executed manually, for instance, large-scale performance testing, and improve the quality of test activities by allowing for more consistent testing and a higher level of defect reproducibility, while increasing reliability of testing, such as automating large data comparisons or simulating behavior. Tools can be classified based on several criteria, such as purpose, pricing, licensing model, and technology used. Another option is to use activity types. Some tools clearly support only or mainly one activity. Others may support more than one activity but are classified under the activity with which they are most closely associated. Some types of test tools can be intrusive, which means that they may affect the actual outcome of the test. For example, the actual response times for an application may be different due to the extra instructions that are executed by a performance testing tool, or the amount of code coverage achieved may be distorted due to the use of a coverage tool. The consequence of using intrusive tools is called the probe effect. Management tools may apply to any test activities over the entire software development lifecycle. Examples of tools that support management of testing and testware include test management tools and application lifecycle management tools, requirements management tools for traceability to test the objects under test, defect management tools and configuration management tools, and also continuous integration tools. Tools that support for static testing. Static testing tools are associated with the activities and benefits, such as the examples described in the section of the static analysis of code, for instance, unused code, dead code, and initialized variables. Tool support for test design and implementation, where the tools aid in the creation of maintainable work products in test design and implementation. That includes test cases, test procedures, and test data. Examples of these tools include model-based testing tools, test data preparation tools. In some cases, tools that support test design and implementation may also support test execution and logging or provide their outputs directly to other tools that support test execution and logging. Tool support for test execution and logging include test execution tools such as run regression tests and coverage tools such as requirement coverage, code coverage, and even test harnesses. Tool support for performance measurement and analysis are essential in supporting performance and load testing activities because these activities cannot effectively be done manually. So examples include performance testing tools and dynamic analysis tools. Tool support for specialized testing needs that work in addition to all of the above mentioned tools that support general test process. There are more specific testing tools for non-functional characteristics. Simply acquiring a tool does not guarantee success. Each new tool introduced into an organization will require effort to achieve real and lasting benefits. There are potential benefits and opportunities with the use of the tools in testing, but there are also risks. This is particularly true of test execution tools. Potential benefits of using tools to support test execution include reduction in repetitive manual work, for instance, running regression tests, or even for environment setup and teardown tasks, thus saving time. Greater consistency and repeatability, including test data that is created in a coherent manner and tests are executed by a tool exactly in the same order and with the same frequency. More objective assessment, for instance, using static measures and coverage, and easier access to information about testing, statistics, graphs about test progress, defect rates, and performance. Regarding the potential risks of using these kind of tools to support tests, the tool may be relied on too much. It can even be seen as a replacement for test design or execution, and the use of automated tests where manual testing would be better is an issue. Version control of test work products may be neglected. Relationships and interoperability issues between critical tools may be neglected, such as requirements management tools, configuration management tools, defect management, and tools from multiple vendors. Another aspect regarding this is that the tool vendor may go out of business, retire the tool, or sell the tool to a different vendor. And this includes aspects where the vendor may provide a poor response for support, upgrades, and defect fixes. An open source project may be suspended, for instance. A new platform or technology may not be supported by the tool, and there may be no clear ownership of the tool. For instance, mentoring, updates, and furthermore. In order to have a smooth and successful implementation, there are a number of things that ought to be considered when selecting and integrating test execution and test management tools into an organization. Test execution tools execute test objects using automated test scripts. This type of tools often requires significant effort in order to achieve significant benefits. Capturing test approaches by recording the actions of a manual tester that might seem to be attractive, but this approach does not scale to a large number of test scripts. A captured script is always a linear representation with specific data and actions as part of each script. It is unstable when unexpected events occur and require ongoing maintenance as the system's user interface evolves over time. Data-driven test approach separates out the test inputs and expected results, usually into a spreadsheet, and uses a more generic test script that can read the input data and execute the same test script with different data. Keyword-driven test approach. This test approach provides a script where keywords are processed, and those keywords describe the actions to be taken. They are also called action words, which then calls keyword scripts to process the associated test data. All of the above approaches require someone to have expertise in a scripting language, such as testers, developers, or specialists in test automation. When using data-driven or keyword-driven test approaches, testers who are not familiar with the scripting language can also contribute by creating test data and/or keywords for these predefined scripts. Regardless of the scripting technique used, the expected results for each test need to be compared to actual results from the test either dynamically while the test is running or stored for later post-execution comparison. Test management tools often need to interface with other tools or spreadsheets for various reasons. to produce useful information in a format that fits the needs of the organization, to maintain consistency and traceability to requirements in a requirements management tool, to link with test object version information in the configuration management tool, and this is particularly important to consider when an integrated tool includes a test management module as well as other modules that are used by different groups within an organization.